All right, we're back, and for what should be a very exciting module for this course, probably the one that I'm personally most excited about, because this is where we can get into image processing, changing pixels, and we can start to actually have some fun with images in here. So before we get to that, let's discuss what images are, how we can deal with them in Swift and within the iOS environment. So images are essentially 2D arrays, but you don't just have one 2D array, because each image is represented normally by a red, green, and blue channel. So the red channel is a 2D array, that every point is a pixel that has a red value. Then you have a same 2D array for green, and then same 2D array for blue. Now, sometimes you have images that have a certain amount of opacity, so that you could have an alpha channel as well. So the standard notation of an image is that it's an image that has a red, green, blue, and alpha channel. So 4 channels representing 4 2D arrays that are pixels representing each point on the image. So, for example, here we have an image just taken outside the Monoface office. We made this image small, and I'll tell you why in a second, but the idea is that, well, it's just an image of office buildings. And we're going to be playing with this image, changing the channels, adding some filters, and essentially understanding how we can manipulate an image in Swift. So there are a few things to get started. First, you might see on the left side in very small font the RGBA image.swift, and that's a class that we've made that allow you to essentially open an image and read the pixels. So Jack, do you want to mention more about this?
Yeah, sure. So on iOS, if you're just reading and displaying an image, you don't have to ever worry about how it's stored. Like Parm just mentioned, it's channels or anything. You can just get an image, and you get it in this UI image class, and you can just create them using by calling the initializer called named. And since in this storyboard we have this file called scenery, this will give us an image. And we can unwrap it. And this doesn't really hold the pixels because you want to store it. I mean, it's trying to be as efficient as it can. And for every pixel, if you're storing it as arrays, it takes up a lot of space. So if you're just displaying it, you don't actually get access to the pixels. And so what we've provided is a way, the RGBA image, which stands for red, green, blue, and alpha, which are the 4 channels. And it's a very standard way to store images in memory. All this code that you don't really have to read basically just takes a UI image and does a bunch of stuff to read out its pixels as an array in a buffer. And it gives you this unsafe mutable buffer pointer, which is really just a way that Swift deals with pointers coming from C. And so you can think of it as just a one-dimensional array of pixels. And outside of its name, you use it exactly like a array.
And so by the 1D array, what Jack means there is that essentially your 2D arrays of red, green, and blue, they're stacked to be a 1D array, meaning that you first essentially have the red value, the green, the blue, and the alpha for the first pixel. And then you go on to the next pixel until you finish the first row. And then the next one, so that your row plus one's item in this array is then the next row. So you keep cascading these throughout, and you essentially get a 1D array, but that represents your image.
Yes. So the width and height are also stored in this class. And there's one more method that after you're done playing around with the pixels, you can get an image back so that you can display it. Because iOS does require you to have a UI image to do any sort of displaying. So the pixel class is here. And it stores the value as a 32-bit integer. And I guess the format we're storing here is called RGBA32, which means I use 32 bits in total for each pixel. So each of red, green, blue, and alpha are stored with a 8-bit integer. And so all this class does is allows you to easily access red, green, blue, and alpha of a pixel, and also set them. So when you read them, you're actually just masking, and we saw this in the previous lecture. These are computed properties. They don't actually store anything. But when you access the red, it just takes the value and masks out the last 8 pixels, which is the value for red. And when you set it, it takes your new value and masks it into the value. Yeah, so this is, for this module, how you'll be dealing with images, and we'll show you an example soon.
And so what is happening here when you're reading these values, essentially you shift it to the right to make sure you access the right set of pixels for the red, green, blue, or alpha channel, and then you mask it. Now, when you're setting it, essentially you shift it back, like you said, and you essentially want to make sure that whatever you're shifting, only the values that you have shifted are in there. Anything else essentially is left out.
Yeah, so I guess it might be easier to visualize it a bit. So say you have a pixel, which is basically this is a color, which is 8 bytes, in which we can represent, like say like A, B, 1, 2, 3, 4, 5, 1, F, A. I think that's correct. So each of these, no, that's too many. 1, 2, 1, 2, 1, 2, 1, 2. Okay, so what this means is basically, here's your A, here's your B, here's your G, and here's your A. I mean R. So it's kind of backwards, but that's just how the bytes are stored in memory. So that's what value would be. So if you're accessing red, you want to take out 51 in this case. And how you do that is using a bitwise and passing in a mask. So what you pass in is a FF, and I guess it's easier to see as bits.
Yeah.
So FF is basically 16 ones, or no, sorry, 8 ones. And when you AND with it, all the zeros will get removed. And once you do this AND, all you are left with is 51.
Right.
But so in the green case, if you want the green, then what you do is you shift the green over so it's now in the place of where 51 is, and we don't worry about where 51 went or the other ones. And then you AND with the FF, so now you get 43. And when setting it, what you do is say you want to set green, then you shift this over to the left to the same spot, and then you...
Essentially, you have to, in this case, now erase what was there before. So this part, this essentially is erasing the green value you have right now. So it keeps the alpha, which is these two hex values, the blue and the red, but the green is now added with 0, so this wipes out the green to 0. And then you OR it with the new value you're putting.
Yes. And that allows you... So this allows you to set sort of two bytes at a time into this, 1 byte at a time into this value.
Yep. Okay, great. Now this this file we will provide you. So make sure if you're following this course or this module, you download this so you have this in your to actually work with. You don't have to recreate this from scratch. We don't have that expectation right now. But you should be able to now, using this, be able to manipulate images as we'll do in a second.
And if you can download this entire storyboard, like exactly how you see it right now, without this, so it'll be blank. But yes, this will be provided. You can go download that right now.
Okay. So next, what we're going to do is for the next section of this module, we'll come back and we'll start playing with images.